Hi class, in this video we want to talk about what are exponential functions, and I also want to talk about what their graphs look like. So they're going to look kind of like polynomials. When we had polynomials, those were a variable raised to an exponent that was a constant, so like 5 to the power 3 or x to the power 2, or even the number 6 we could write it as x to the power 0. So each of these is a variable raised to an exponent that is a constant, 0, 2, and 3. When we talk about an exponential function, we're going to switch the roles of those two. Which one is playing the role of base and which one is the exponent. So in an exponential function, the variable is in the exponent and the constant is the base. So instead of x squared, we're talking about 2 to the power x and 5 to the power x and 0.3 to the power x. And sometimes we'll have numbers multiplied by those. Other times it'll just be like a number raised to a power. So we'll see it a few different ways. So that's the main difference, is that your x's are in the exponent instead of in the base. So when we make our little table, we're going to have the exponents changing instead of the bases changing. So speaking of tables, we're going to make a table and try and graph a few of these. So just let's see, which ones do I want to try? Let's try to graph 2 to the x. Seems like a nice simple one. I'm not going to do these two though. I'm going to pick simpler ones. I'm going to pick 3 to the x, and I'm going to pick 1/2 to the power x. So let's try and come up with a table for each one of these, then we'll make a graph. Okay, so x and f of x equals 2 to the power x. So again, I'll plug in my normal numbers, -2, -1, 0, 1, 2. If that's not enough for me to start to see a pattern of the shape, I'll plug in more numbers. So let's see, this is 2 to the power -2, and 2 to the power -1, and 2 to the power 0, and 2 to the power 1, and 2 to the power 2. Okay, if you wanted to, you could use a calculator. We've also talked about negative exponents before. A negative exponent moves you to the denominator, and 1/2 squared would actually be 1/4. And same thing here, 1/2 to the first would be 1/2 or 1/2. And if you wanted to, you could turn these into a decimal to call this 0.25 and 0.5, whatever you want to do. I'll just go real quickly through the last ones because we know anything to the 0 power is 1, to the 1, and 2 squared we've seen before. Okay, so let's hold off on the graph for just now, and let's finish our other two tables. So x and g of x equals 3 to the x. So again, plug in numbers like -2, -1, 0, 1, 2. 3 to the -2, 3 to the -1, 3 to the 0, 3 to the 1, 3 to the second. And same thing for h of x. So 1/2 to the -2 power. So let's see if we can remember. So when we have a whole number to a negative exponent, it moves to the denominator. When we have a fraction to a negative exponent, it flips upside down. So it would be 2/1 squared. And 2 squared would actually just give me 4. And let's see, 1/2 to the -1 would be just 1/2 upside down, which is 2. 1/2 to the 0, anything to the 0 power is 1. 1/2 to the first, anything to the first power is itself. And 1/2 squared is 1/2 times 1/2, which would be 1/4. Okay, so we have a bunch of points. Let's see if we can graph them all. Actually, as I start to graph this, notice all of my y values, so that's the f of x or the g of x or the h of x, every single one of them is a positive number. So I don't actually need the bottom part of my graph. I only need the top part. Okay, so we have our x and y axes. Let's start plotting points. So -2, 1/4, -2, 1/4, -1, 1/2, -1, 1/2, 0, 1, 1, 2, and 2, 4. Okay, and if I wanted to, I could plot another point. The next point would be x is 3, y is 2 cubed, x is 3, and so 2 to the third power would be 8, which would actually give us this point over here. And so our pattern is it's getting steeper and steeper and steeper. And so there's a few ways I could describe this graph. We could say that it is growing exponentially. It's getting steeper and steeper and steeper, taller and taller and taller. That's what we mean when we say growing exponentially. It means this kind of an equation where the x is in the exponent. It means it's going to grow even faster than a polynomial would grow. If we try and do the same thing for 3 to the x, well, yeah, let's go ahead. We have -2, 1/9, -1, 1/3, 0, 1, goes through the same point, 1, 3, and 2, 9. So 3 to the x is a little bit steeper. And it's a little further down and to the left. So it's this one over here. Should have picked a different color. Oh, 1/2 to the x, if we plot all those points, -2, 4, -1, 2, 0, 1, 1, 1/2, and 2, 1/4. Okay, so a couple of things to notice about these different shapes. If I look at just the original 2 to the x, this first one, we start at height 1/4, then 1/2, then 1, then 2, then 4, then 8. And so if you notice, we're doubling our height every time. If you look at 3 to the x, what we're doing is we're multiplying by 3, and multiplying by 3, and multiplying by 3, and multiplying by 3. So any exponential, you're multiplying by this base every time. When I say every time, I mean when your x goes up by 1, meaning you take 1 step to the right, your height is going to double or triple, or in the case of 1/2 to the x, your height is going to get multiplied by 1/2. That's the reason why this one is going down instead of going up. So all of our exponentials are going to look like either this shape that goes up or the shape that goes down. And whether it's a 2 to the x or a 3 to the x, slightly bigger numbers are going to be slightly steeper, slightly smaller numbers are going to be slightly shallower, and once you get really small, then you're going to start decreasing. So let's just write a quick rule on what that's going to look like, and then I think that'll be it for this video. So our general idea is when we have an a to the x, we're going to have two cases. If a is a big number, it's going to be increasing, so our shape is going to look kind of like that 2 to the x. If our a is a small number, it's going to be decreasing, so it's going to look kind of like that 1/2 to the x. And so the difference is going to be, are you bigger than 1 or are you smaller than 1? We're actually going to always use positive numbers, but numbers bigger than 1, so think about them as percents. If you're more than 100%, you're increasing by that amount. If you're smaller than 100%, you're decreasing over time.